Okay, so let's review how to solve an equation with a rational exponent. A rational exponent is simply a fraction as an exponent. Now, if you remember, a fractional exponent or a rational exponent is just another way to write a radical. So I could write this same left side of the equation as the 9th root of 5x plus 3 squared. So an easy way to remember this is that the root of the radical goes on the bottom of the fraction. And you can think of a flower, and a flower, its roots are on the bottom. So that's where that would go. The radical index is always on the bottom. Okay? And the radicand is going to be the base of the exponential function. Okay? So realizing that it's just a radical, it's just another way to write a radical. When we want to solve it, we can easily solve it by raising each side to the reciprocal of the exponent. So if I have an exponent of 2/9, then I'll just raise it to the power of 9/2 on both sides. We do this because we know that 2/9 times 9/2 equals 1. So if we simplify the other side, 1 raised to the 9th power is 1. If we take the square root of that, that's going to be 1. Or we can use our calculator and just enter in 1 and then use the little caret button and type in 9/2. That's another way to evaluate that. So if I want to solve this, I'll say 5x is equal to -2, and I'll divide it by 5, and I'll get x is equal to -2/5. On these problems, you have to check your answer to make sure you haven't created an extraneous solution. And the way we check our answer is by putting it back into the original problem. Wherever there was an x, I'm going to replace it with my solution of x is equal to -2/5. And I'll get 1 is equal to 1, and it is true. So x is equal to -2/5 is my solution. My next problem has a fractional exponent of 3/2. Before I can do anything, I have to get my fractional exponent expression by itself. So I'm going to isolate it by adding 1 to both sides. Now, when I have a fractional exponent, I can raise it to the reciprocal. So the reciprocal or flip of 3/2 is 2/3. And I have to do it to both sides. Whatever I do to one side in algebra, I have to do to the other. So we know that 3/2 times 2/3 is 1. So I'm left with the base. And this will be 8 to the 2/3. I can put it in my calculator, or I can think to myself, that means it's the cube root of 8 squared. That's going to be 2 squared is going to be 4. So if I solve this, I'll say 3x is equal to 11, or x is equal to 11/3. Now I have to make sure I check my answer. I replace x with 11/3. I'll get 11 minus 7 raised to the 3/2 minus 1 is equal to 7. So 4 to 3/2 minus 1 is equal to 7. So if I put this in my calculator, then I'll get 8. 8 minus 1 is 7. 7 is equal to 7, so that's correct. So my solution is x is equal to 11/3. Let's try one more. So my exponent is 3/2. So I'm going to raise both sides to the reciprocal, which is 2/3. So when I raise the left side to 2/3, 3/2 times 2/3 is equal to 1, and I'm left with 2x minus 4 is equal to, and then 1 to the 2/3. Well, 1 to anything is 1. So I'll add 4 to both sides. And I'll get x is equal to 5 halves. So let's check our answer. So I'll end up with 5 minus 4 to the 3 halves is equal to 1, which will be 1 to the 3 halves, which we know is 1. So 1 is equal to 1. So our solution is x is equal to 5 halves. Let's review also, how do you solve a rational equation when you have one fraction equal another fraction? So when you have a fraction equal to another fraction, a proportion equal to another proportion, and you only have one on each side, then you can use cross multiplication. You can multiply the numerator of the left side times the denominator of the right side and set it equal to the denominator of the left side times the numerator of the right side. And this is called cross multiplication. It only works though when you have one fraction equal another fraction. So let's apply this to our equation. Now, before I start, I'm going to mention that I have a minus in front of this right side, and it's a fraction. And so oftentimes people are confused what to do. Now, when you have a minus, you can put it in the numerator, or you can put it in the denominator. But you cannot put it in the numerator and the denominator. You can choose either one. So let's just, for this problem, let's just stick it in the numerator. And let's cross multiply. So we're going to say x plus 7 times x plus 4 is equal to x minus 5 times negative 18. So we're going to want to expand this out by multiplying. So you can FOIL or you can distribute, whatever method you like. And I'm also going to multiply the negative 18 and distribute it to both the x and to the 5. Okay, now you can see this is going to be a quadratic, and I know that because it's the highest exponent is a 2. So I'm either going to use quadratic formula or zero factor property. I always start with the zero factor property, and if it's not factorable, then I use the quadratic formula. But both need to be set equal to 0. So I'm going to add 18x to both sides, and I'm going to subtract 90 from both sides. And let's just clean this up. So I'll combine my like terms. And let's go ahead and factor this. If I'm having problems finding the factor pair that multiplies to be negative 62 and adds to be 29, just a reminder, you can use your calculator. To do this, you multiply a times c, which in our case would be just negative 62, and you put it in your graph for y1 is equal to negative 62 divided by x. And then if you hit second graph, it gives you all the factor pairs. Okay, so we're only looking at the whole numbers, and we want a pair that adds up to be 29. So I'll stop and hesitate. So I can see that 2 plus negative 31 would give me a negative 29. So if I use negative 2 plus 31, it will give me a positive 29. And I'll set each factor equal to 0. And I'll solve, adding 2 to both sides and subtracting 31 from both sides. And I have to check. Remember, for rational expressions and radical expressions, you have to check because you might get these pesky extraneous solutions. So you have to always check. So let's check x is equal to 2. So I put it back into my original equation, replacing x with 2. And it turns out to be a true statement, so I know that this x is equal to 2 is a solution. Now let's check x is equal to negative 31. And when I evaluate the expression or the equation for x is equal to negative 31, I see that it's a true statement. 2/3 is equal to 2/3. So this means that x is equal to negative 31 is also a solution. Now, we're going to apply what we just reviewed to solve using substitution, where we're going to reduce each of these equations into a quadratic form equation so that we can solve it. So Right now we have x to the fourth, which we haven't learned how to solve. So far we've only learned linear and quadratic. So what we're going to do is we're going to look at our largest exponents, and whatever it is, if it's a variable or a variable expression, we're going to write it, and then we're going to let it equal u squared. And this is going to be our substitution. I want this to be ax squared plus bx plus c. But you can see we want this to be an x squared and we have an x to the fourth. So I'm going to make the substitution. And the way I do that is I write whatever that variable or variable expression is, I set it equal to u squared because I want this always to be a square. I want to take the square root of both sides just so I can see what u would be. So u would be x squared if I took the square root of both sides. Now I can make these substitutions into my real equation. So we know that x to the fourth is the same thing as x squared. That's what our substitution is saying. So we're going to substitute that out. And x squared, we're going to use the substitution of u. Now, this is not our real equation, right? But this has been reduced to a quadratic form equation that we can solve. And I can just use this factoring and use the zero factor property by setting each factor equal to 0. I only need to write it once since I have the same factor. And I say that u is equal to negative 1/2. But you're not done. And oftentimes students will stop here and they forget. It asked me to solve for this original problem that had x's. I want to find out what x is equal to. And I have u is equal to negative 1/2. So I have to go back to my original substitution and I want to reverse substitute. So I said that x squared is equal to u. So I'm going to replace u with x squared. And now I want to solve for x. To solve for x, I'm going to take the square root of both sides. And when I take the square root of a square, I get the radicand. When I take the square root of a number, I'll get plus or minus that square root. Now, I could rewrite this as plus or minus the square root of negative 1 times the square root of 1/2. And I could do that because I know that the square root of negative 1 is I. Let me write that over here. So that's going to be plus or minus, and that's going to be I. And then that'll be times the square root of 1/2. So x equals plus or minus I times the square root of 1/2. And typically we like to have the number in front of the I, so you may see that the book may rearrange it as the square root of 1/2 times I, or they might just write that it's approximately 0.7 times I. And we can find that by taking the calculator and taking the square root of 1/2. Let's do another one. We're going to solve this using substitution. I will definitely give you the cue on the test with solve using the substitution. And I probably will have something like that'll say using the quadratic reduced form to give you an idea to watch for it. So right now we have an exponent of 2/3, but I want to make this a square. So I'm going to let x to the 2/3 equal u squared. I'm going to always set it equal to u squared. Now, I want to find out what u is. So I'm going to take the square root of both sides, which is the same thing as multiplying or raising both sides to the power of 1/2, if you like to think of it that way. So you can see this side would become 2/3 times 1/2, which would be 1/3. So these are our two substitutions we're going to use. So in place of x to the 2/3, I'm going to replace that with u squared, because that's what we said x to the 2/3 is equal to in our substitution. And in place of x to the 1/3, I'm going to replace it with u. So I have 8u squared minus 16u. I'm going to factor it and set each factor equal to 0. And I get that u is equal to 0 and u is equal to 2. But whoa, you're not done yet. The answer asks you to solve it in terms of x. We want to solve for x. So we have to remember to reverse substitute that u is equal to x to the 3rd. So we're going to raise both sides to the reciprocal, which is 3/1. So the left would become x, and 0 to any power is 0. And 2 to the 3rd power is 8. So our two solutions we think we have are 0 and 8, but we have to check them. So let's check x is equal to 0 first. Zero raised to anything is 0. Well, that one definitely is true. Now let's check x is equal to 8. If you're not comfortable thinking of these as radicals, use your calculator and just raise them up. So this would become 4, and this will become 2. So it'll be 32 minus 32, and that is equal to 0. So x is equal to 0 and x is equal to 8. Both are solutions. Let's do another one. Now, you want to make sure that you're equal to 0. So if for some reason you don't have it equal to 0, make sure you rearrange it so that it is and solve. So I'm going to subtract I'm going to subtract 7x to the -1 power, and I'm going to get 6x to the -2 minus 7x to the -1 minus 3 is equal to 0. And notice I put them in the right order as far as if I have a 2 or a 1 on the left. Okay? So I'm going to look at my far left term, and I'm going to say let x to the -2 equal u squared. I'm always going to set it equal to u squared. Okay? So if I take the square root of both sides, that's the same thing as saying raise it to the 1/2 power. I do that to get my u as just to the exponent of 1, and 2 times 1/2 will give me 1. On the left side, I'll have a -1, and we could write that as 1 over x. Remember that a negative exponent means that the base, if you move the base, then the exponent will become positive. So I could also rewrite this one as 1 over x squared. Okay, these are both substitutions. 6x to the -2 minus 7x to the -1 minus 3 is equal to 0. And we're going to substitute x to the -2. We're going to call that instead u squared. And x to the -1, we're going to call that u. And I'm going to go ahead and solve this. So I factored it, and I'll set each factor equal to 0. And I'll solve. And I'll get u is equal to -1/3. And u is equal to 3/2. But you're not done yet, because you want it in terms of x. So we're going to replace with a reverse substitute our earlier substitution. So earlier we said that x to the -1 was equal to u. Now we're going to say u is equal to x to the negative 1. So we can think of this a couple ways. It might be easiest to just say 1 over x is equal to negative 1/3, and 1 over x is equal to 3/2. And then you can use our cross multiplication technique. So moving up here. So we'll cross multiply it. 1 times 3 is 3, and x times negative 1 is negative x. Remember, we're not solved though unless we have a positive 1 coefficient. So we'll say x is equal to negative 3. And we'll do the same thing over here. 1 times 2 is 2, and x times 3 is 3x, and we'll divide by 3, and we'll get x is equal to 2/3. Now we have to check both of these in our original equation to make sure that they're valid answers. Let's check x is equal to negative 3. When I replaced x with negative 3, I found that I got a true statement, so x is equal to negative 3 is a solution. Now let's check x is equal to 2/3. And when I checked this and replaced x with 2/3, I ended up with a true statement. So this is also a solution. So we have two solutions. Our next problem is not equal to 0, so let's rearrange it so that we have equal to 0. So I'm going to add the square root of x and subtract 6 from both sides. And I'm going to get 15x plus the square root of x minus 6 is equal to 0. Okay? So let's rewrite this using exponents that are fractional rather than radicals. Now we're going to let x equal u squared. And then we're going to take the square root of both sides and we'll say x to the 1/2 is equal to u. And we'll make our substitution. And so we're going to use this and we're going to replace x with u squared. And we're going to replace x to the 1/2 with u. And now that it's reduced to a quadratic, we're going to solve using the zero factor property and set each factor equal to 0. And we're going to get u is equal to 3/5. And u is equal to negative 2/3. But whoa, you're not done yet. The problem didn't want to know what u was equal to. It wanted to know what x was equal to. So we're going to reverse substitute and we're going to replace u with x to the 1/2. To solve for x, I'm going to raise both sides to the reciprocal of 1/2, which is 2. And I'll get x is equal to 3/5 squared, which is going to be 9/25. And I'll do the same thing on the other side. And I'll get x is equal to 4/9. Now, I have to check my answers. Remember, when you're dealing with radicals and you're dealing with rational equations, you have to check your answers in case you've created extraneous solutions. Let's check 9/25 first. So I replace x with 9/25. And I'll get a true statement. And so since I get a true statement here, I know that x is equal to 9/25 is a solution. Let's check the second one. X is equal to 4/9. I replace x with 4/9. But I realize that I end up with a false statement. 20/3 is not equal to 16/3. This means that 4/9 is not a solution. So I only have one solution, 9/25. So I go ahead and strike 4/9 and I only circle 9/25.